Nice to see everyone. Direct again to Scala meetup version 9. Everyone present. So first I would like to thank our host Scale that gave us the space to do another meetup on Scala and bring everyone together. They might have some future opportunities for Scala jobs. If you will be interested, we might send them later in the future. And today's topic is Scalaz ZIO. And luckily we'll have two speakers today. The first speaker, which I'd like to introduce, is Oleksandra. She has been working with Scalaz ZIO and working with John, who is the founder of Scalaz ZIO framework. And so Alexandra will give an overview of Scalaz ZIO and functional programming in general. And after that, we'll have a break, and John will join our meetup remotely, and he will talk about how we can implement a game using FP principles. So without further ado, one note, we'll have a piece of paper we distribute where you can write questions, but we'll have opportunity to ask questions on a microphone live as well if you want. So it depends on which way you prefer. Alright, so without further waiting, let's start our meetup, and I'll pass the word to Alexandra.
Hello, my name is Oleksandra, and I'm here because I like functional programming. I'm not saying that object-oriented programming is bad. We need to use object-oriented programming because it helps us to reuse our code. But functional programming is not easy. But John, the creator of Scalaz ZIO, showed me how it can be fun and how complicated problems can be solved in a simple way. So, what functional programming is? I mean, do not be confused with functional programming paradigm. Programming with functions based on three principles. So, first principle is totality, which is mean for every input they must return the same output. The second principle is determinism, which means for the same input they return the same output. And also purity, which means they only affect computing a value. So I want to go with a few examples. For example, toInt is so method toInt on our function string is partial because for many strings it does not return an int. Another example, divide1, show this function is not total. Why is this function is not total?
Zero case.
Yes. So when we go to a terminal, for example, and we will try. So we will try to divide one. Divide by 0. So we will build. Oh, okay. Okay. This function is not found, but. Oh yeah. Yeah. Sorry about that. Thanks for helping. Yeah, I think I'm right. Okay. Yes. And we got an exception. So, well, how to convert this function to deterministic? We need to use pattern matching here. And in case of none, in case of 0, we will have just none. So let's take a look how it works. Okay, so here we have none, and our function is total now. And let's go to determinism. So this function is not deterministic because for every input, the result will not be the same. For example, our fresh ID 1, and result will not be the same. So how to convert this function to deterministic? We can use ID as a parameter and also add int as output and increase it ID plus 1. So let's see how it works. So we define it, our fresh ID 2. Let's say that we want to have here, which will be typed like int, and will be return plus int and also equals to ID2, and our increased ID was 1. Okay, so let's see how this function can work. Oh, sorry. Um, let's say that we want to increase 5, for example. So, and we have 5 here, and also it increases number 6, so which is mean our function deterministic. And I want to spend some time on purity, and I want to explain what is referentially transparent. So here, for example, so let's introduce our expression to value x will be so equals to 4, and let's say that x plus x compares with the comparison here. Plus
You have a type of lens.
Or is my
This previous lens, test lens type.
First,
I'm always
Yeah.
yeah.
No, the second is right.
first one is wrong.
Or not.
Oh, I see. Sorry. Okay, and this is true. So sorry about this mistake. I'm always um, confusing with this T and H every time.
It's okay.
And we can see that this our expression is referentially transparent, and we can assign this expression to x, and x can be used everywhere in our program. So we can conclude that this expression is pure because of definition. So let's take a look at our definition. A function f is pure if the expression fx is referentially transparent for all referentially transparent values of x. As we proved above, our expression is referentially transparent, so this is pure. This expression was pure, and now I want to jump to our pure function. So this function impure because in order to test this function is too complicated because okay, let's see. So and type will be a string equals to so in pure function the output should be should be string, but here we see a unit, and how to do this, how to convert this function to pure, for example. Oh, yeah, I see. Scala is not easy. Once again. Okay, here it goes. And this function is pure, and we have a string. And so now we know three principles of Scalaz ZIO, and three principles of purity. And let's jump into Scalaz ZIO. And yeah, also some benefits of programming with functions. So pure function is easy to test and easy to combine, easy to reason about because of no hidden input and output. So you know what function does by just looking at its signature. And also pure function is easy to debug and easy to parallelize. So let's talk about zero. And what is zero? So zero provides a general purpose effect monad for an associated abstraction for purely Scala applications. So effect monad like AYA are how purely a functional program interacts with the real world. And let's talk about what is IO. Also, you can go at GitHub Scalaz ZIO and download ZIO and see how it works. By examples, it has some examples. So what is IO? IO is just immutable value, like a list. All methods in IO is return new IO values derived from original. Because IO is an immutable data structure, you can model effect while still benefiting from all the reasoning properties of functional code. So your main function can extend application which provide a complete runtime system and allows the entire program to be fully functional. So IO ain't nothing to run. To use IO, you need to run a program, and IO ain't nothing, never computes a value. For example, why do we need that? If we want to run a program forever, we can use IO ain't nothing. Also, IO nothing A is never fails, and IO nothing is never fails and never computes a value. What is? Let's take a look at second class effects and first class effects. For example, we have second class effects and we have first class effects. And why this function is not so good? So first line of the function refers to value name, and if this line value name is unit, if line println is unit, we may So first line of this function refers to value name, but definition of this program is not transparent, because if this line is unit, then next assignment to value can be ignored, okay, or may not be ignored. So who knows? And we can convert this second class effect to a first class effect by using just I-exception unit, and it will work. So brackets, we using brackets in ZIO instead of try-catch finally. So why do we use brackets? Because brackets, because try-catch finally can swallow exception, and also try-catch finally can't run asynchronously, for example. But with brackets, bracket can run asynchronously and synchronously also. And we need to use much less code for brackets. Next, I want to talk about fibers. Fibers we use in fibers in ZIO that help us to not block our process. Because, for example, if we take a look at our Fibonacci, this is a standard example of Fibonacci. And let's take a look at Fibonacci in ZIO. So we have fiber 1 and we have fiber 2. We forking them. And then we have 3 fibers. We have forked fibers and also joined fibers. And also we have sum of this result. So thanks for your attention, and we can go to GitHub Scalaz ZIO, and also we can go to the GoISnet website, and there is some articles, and in a while John the Gois will show game. Thanks for your attention, and maybe it was short, but I forgot all the words. It was my first talk, and maybe second talk will be much better.
Okay. Do we still have a paper with questions somewhere?
Yeah, right.
Does he have anyone who wants to ask a question live? Is there anyone?
Yeah, show us the real meat, please, and then we'll give it questions.
So if someone has a question, they can raise their hand, maybe about ZIO or anything else.
I have a question.
Okay.
Thank you for your talk. My question is, did you use Scalaz ZIO in production or in system? What's your opinion?
Well, I didn't use Scalaz ZIO in production, but I did some methods for Scalaz ZIO, contributing this library, and for me is very. I like to contribute in this library, and I have never tested this library before because I'm writing methods and also I'm creating issues for Scalaz ZIO, and mostly I'm doing functional programming. And Yeah, well, maybe I need to use it with Akka or with some else frameworks.
Okay. Anyone else has a live question? Okay, I can ask. Can you explain, can you go back to the slides a bit?
Yes.
Just go back a little bit. Yes. Yeah. The second one, just two more forward. Now forward. The one that you changed. A string example. Yeah, a little bit forward. No, other direction. Yeah. More. Before we go to brackets, the last slide before brackets. Yes, this one, and then the next one. So I think this one you haven't explained too much because of how you transform first class objects.
Yeah, I forgot to explain this.
Okay, take your time.
Sorry. Okay, so by setting IO exception A, program may fail with exception or produce with A. There is no exception because we have already into IO, we have already set exception here in which is we can substitute here which is IO A, and so we don't need to worry about exception here because and also about empty values.
Okay.
Problem you fix when we use ZIO or IO. What generally I need don't include this library to my project when how I came to decision add ZIO to project or not. Can you take your advice about this question?
Okay.
Would you leave this to John? Because we'll have more practical example in the slides.
Well, I can answer on your question, but also John can answer on your question.
Because I have also some questions. I think it would be more relevant for next talk. So I have some other questions that might be a bit more relevant to your talk. So can you just ask again? Next talk. Okay. So a question: if you need to use side effect functions for requests to remote database. But I'm not sure I got the question, but if you need to use side effect functions for accessing remote database, how would you use ZIO? Maybe some tips.
So ZIO has some tips to use to interact with database also. So you can go to a microsite, and there are some example how to use it. So there are some schedules and features also you can use it, and also John will show some example how to interact with real world.
Okay.
I have one more question. Can you provide your experience about how look like stack trace when something crashed inside the I/O models? So if something happened and I received trash, thread is die, and I received stack trace, how they is readable? Question.
Okay, I have this issue, and I need to post it in ZIO. For example, do you mean when a lot of threads crash it, or?
No, it's a thread. I'm sorry. It's question about generally. Very often people don't use async library like REST Java or React or something like that because they is corrupted stack trace, and when you receive exception, you it's not clarify understanding where exception is happening. So my question is how deal with stack trace when crashes came inside the IO, ZIO, for example.
Well, I need some time to answer on your question. I need to think about your question, and maybe I'll answer later.
Okay.
Or maybe I create some post, and John also arrived, so he look at some place to sit up. So we need to.
Okay. So big thanks to Oleksandra again, knowing that this was your first talk. I hope you imagine that it's there's like a little pressure, especially for them, somebody that hasn't been doing public speaking. So give big thanks, applause to Oleksandra again. We'll have a short break to prepare for a remote talk, maybe 15 minutes. So if anyone just wants to relax, walk around, discuss, we have your time now. And we'll have a next talk, from the host in a few moments. In 10 minutes, we will have also pizzas, so don't run away far. Have a snack.